Today, we're tackling one of the biggest mysteries in the universe, the Fermi Paradox. You've probably heard it summed up as, where is everybody? The universe is massive. Billions of stars, countless planets, many potentially habitable. So why haven't we found aliens? No signals, no spaceships, no ancient ruins on Mars, just silence. In this video, we'll explore why that silence exists. Is intelligent life vanishingly rare? Are aliens hiding? Or are we just not looking hard enough? We'll dive into the history, the science, and some wild theories that might explain it all.
So, what is the Fermi Paradox? Picture this. It's 1950 and a group of brilliant physicists are having lunch. They're joking about aliens, maybe sparked by a quirky cartoon about UFOs stealing trash cans. Then, one of them, a genius named Enrico Fermi, who helped build the atomic bomb, looks up and asks, "Where is everybody?" That question cuts through the laughter. It's not just a quip, it's a challenge to logic. Here's the deal. Our galaxy, the Milky Way, has about 200 billion stars. Many have planets. Some estimates say 100 billion planets total. Even if only a tiny fraction are habitable, that's millions of potential homes for life. The galaxy is 13 billion years old. If intelligent aliens exist, they've had billions of years to evolve, build tech, and spread out. Even traveling at 1/10 the speed of light, slow by sci-fi standards, a civilization could colonize the entire galaxy in a few million years. That's nothing on a cosmic scale. Yet, we see nothing. No radio signals, no megastructures, no interstellar visitors. That's the paradox. The math says aliens should be everywhere, but the evidence says they're nowhere. There's a common misconception here. Some folks think we've scoured the skies with telescopes and radio dishes, finding zero proof of aliens. But that's not true. We've barely looked. Searching for alien signals isn't a full-time job for astronomers. It's more like a side hustle. There's never been serious funding for massive, systematic searches. So the silence might just mean we haven't tried hard enough. To understand why this question haunts us, let's zoom out to the history of wondering about aliens. Humans have been curious about other worlds for ages. In ancient Greece, some philosophers argued the universe is infinite, made of the same atoms everywhere, so other worlds with life must exist. Others thought Earth was special, the only place with life. These debates got heated, sometimes dangerously so. By the 1600s, after Newton's laws showed stars are like our sun, people started imagining distant planets with their own ecosystems. The 1800s brought Darwin's evolution, making folks wonder if life evolves easily elsewhere. But early 20th century astronomers were skeptical. They thought planets were rare. Fast forward to today, telescopes have found thousands of exoplanets. We now know planets are common, and many orbit in the habitable zone, where liquid water could exist. So the question isn't whether planets exist, it's why they seem so quiet. The galaxy's timeline makes this weirder. Stars began forming 13.6 billion years ago. The Milky Way stabilized about 10 billion years ago. Our sun? A latecomer at 4.6 billion years old. That means alien civilizations could have a 5 billion year head start. They should have had time to build empires across the stars. So where are they? One answer might be that life is common, but complex life is incredibly rare. Let's look at Earth's history for clues. Life appeared here fast, maybe within 400 million years of the planet forming, around 3.7 to 4 billion years ago. That's quick on a cosmic scale. But for the next 3 billion years, life stayed simple. Think microbes, bacteria, maybe some slimy mats on ocean rocks. No animals, no plants, just single-celled organisms. Imagine Earth's history as a 24-hour clock, where each hour equals 200 million years. The sun forms at 1 a.m. Life kicks off by 5:30 a.m. But complex cells don't show up until early afternoon. Animals, like those weird Cambrian critters with claws and eyes, don't appear until 9:21 p.m. Dinosaurs? 10:57 p.m. Humans? 1 second before midnight. Recorded history? 1/10 of a second. For over half of Earth's existence, life was stuck at the microbial level. Even now, most of Earth's biomass is simple organisms. Your body hosts trillions of bacteria, more than all mammals on the planet combined. Evolution runs billions of experiments daily with microbes, but they rarely change in big ways. Multicellular life, think plants, animals, fungi, evolved maybe 24 times, but that's a drop in the bucket compared to the number of microbial species. Why the delay? Energy. Simple cells, called prokaryotes, can't produce enough power to support big genomes or complex structures. They're like tiny batteries with limited juice. To get past that, something extraordinary had to happen. Here's where it gets wild. About 2 billion years ago, a 1 in a trillion event changed everything. An archaeal cell swallowed a bacterium but didn't digest it. Instead, they formed a partnership. The bacterium became mitochondria, the powerhouses in our cells. This process, called endosymbiosis, was a freak accident. Every complex organism on Earth, from jellyfish to you, descends from that single moment. Why does this matter? Mitochondria let cells produce thousands of times more energy per gene. That's like upgrading from a bicycle to a rocket. Suddenly, evolution could afford bigger genomes, protective nuclei, and the machinery for multicellular life. Without this, life stays simple. Think algae or lichen, not brains or spaceships. This leap might be what's called the Great Filter, a massive barrier most planets never cross. If complex cells are this rare, the universe could be full of microbial life, but almost no intelligent civilizations. Picture countless planets with slimy oceans, but no one to build a radio tower. That could explain the silence. But what if intelligent aliens do exist, and they're choosing to stay silent? Imagine the galaxy as a dark forest, where every civilization is a hunter hiding in the shadows. Revealing yourself could be deadly. This idea, called the dark forest hypothesis, is like cosmic game theory. Think about Earth's history. When civilizations expand, it often leads to conflict, wars, colonization, competition. Aliens might assume the same. If they've got a billion-year head start, their tech could be incomprehensible. No leaky radio signals, no obvious megastructures. They might be watching us, but staying hidden, waiting to see if we're a threat. We've been broadcasting radio signals for about a century, so anyone within 100 light years knows we're here. Building colonies on the moon or Mars could make us even louder, more visible. If the galaxy is a dark forest, that's risky. Advanced aliens might stay quiet to avoid predators, or they might be the predators, waiting for us to slip up. But there's a flip side. Maybe the silence means aliens evolved differently, prioritizing peace over expansion. If survival means staying hidden, the most advanced civilizations might be the quietest. That could explain why we hear nothing. So where does this leave us? The Fermi Paradox isn't solved, but these ideas, rare complex life, the eukaryotic filter, the dark forest, offer pieces of the puzzle. The silence doesn't mean we're doomed. It might mean we're early in the cosmic game, or that we need to look harder. The exciting part? We're getting better at searching. New telescopes are analyzing exoplanet atmospheres for signs of life, gases like oxygen or methane that could hint at biology. Programs hunting for alien technology, like megastructures or laser signals, are picking up steam. With AI, we can process massive datasets faster than ever. If aliens are out there, we're closer to finding them than at any point in history. If we find nothing, it might mean we're among the first intelligent species, a huge responsibility to shape the galaxy's future. If we do find something, it could redefine everything we know about our place in the universe. Let's wrap this up with a thought. The Fermi Paradox forces us to confront our place in the cosmos. Are we a fluke, a rare spark of intelligence in a microbial universe? Are we being watched by silent, cautious neighbors? Or are we just not looking in the right places? The answer might shape humanity's next steps, whether we shout into the void or listen carefully. What's your take? Do you think complex life is rare, or are aliens hiding out there? Drop your thoughts in the comments. I'll reply to the best ones. If you enjoyed this deep dive, give it a like and share it with a friend who loves space mysteries. Thanks for watching, and keep looking up. See you in the next one.